Hi, my name is Mads Jespersen and I'm from FlowHow. In FlowHow, we have two main products. One is selling and supporting and education in Moldex3D, and the other one is a consultancy business into mainly injection molding projects. But in this video, I want to show you how to set up an analysis, a standard injection molding analysis in Moldex3D Studio R17. So what I will start with is creating a new project, new here, and I'll just call it setup analysis. Okay, and now I have a run here, and then I have to go from left to right. When I've started the project up here in the File Explorer, I have the possibilities to see the setup in here. Analysis, CAD data, material, mesh, and so on. And the MRM file is the database file which you open the project afterwards. Okay, it's injection molding. I can choose different here, but I choose injection molding, and then I import some geometry. This one. This is just a part, not a real production part, but just a part. And then I'll just say this is a part, give it attribute. In this case, I double clicked it. I could also click on it, right click, say edit here. I can change things. Or I could go to attribute, when attribute, mark it, say choose correct. Okay, now we have a part. I just want a simple model because it's just how to set up the analysis. It's not how to mesh things or something. You can look at other videos for that. Then I'll put on a simple gate. In this case, if I have the snap function down here, you can risk that it snaps to something. Sometimes I disable it so I can maybe put it here. But in this case, I'll just put it somewhere. I can, 3 millimeters is maybe too much, 1.6. Okay. I can enable this one again. Now we have a gating system, a very simple one. Go to the mold base and just click OK. Then we have a mold base, and I'll put in some cooling channels. Yeah, I think maybe we should just put them the other way. I can use the scroll mouse now to adjust these. Let's say I want 3 like that, maybe 5, 4. Yeah, doesn't matter really. I'll just place a bit higher and higher. Yes. Click here, and then we have inlet outlet. I can manually put them on here, or I can just check inlet system in this case, and then it gives me a warning. I just hit autofix, say OK. So like that. Now I have a model that's called model here. If I hit save, you can see it gets the name of the part imported. If I want to specify a different name, I right click it and specify model name. Save. And now out in the File Explorer, in the source, I have a MDG file, which is the file containing both the model and mesh. So now I have a model. The next thing is I need a mesh. But before I start with that, I'll just go to Preferences and I'll run the preferences here. File management, computation. I use normally 8 CPUs for calculation because that's what I have maybe license for. Display, I don't use the scientific notation with the tree in the power of 3 and so on. I would rather like the normal human. Graphics, mesh control in boundary layers. I use this one. I put this on up to 11. I use the BIOS layer mesh thickness, generate hex based. I normally use that. In some cases, you could choose not to use it. It will change the difference how a line runner is meshed. And then I use automatic check mesh defects. I don't use this allow non-matching faces. If I have something like part inserts or mold inserts, I always use matching faces because then I'm 100% sure that it works. Yeah, units, nothing, feedback, yeah. Okay, but now I'm ready for the mesh. I go to the mesh. The only thing I have to put some seeding on and do a solid meshing where based on a surface mesh is the part. So I hit this node seeding and pick out the part. And now I have the part here. I go for seeding, let's just say 2. Normally I go for seeding, depends on, you can see this is maybe a bit too rough in the screw towers. But anyway, it's not for making a perfect model. Okay, I can adjust. So I'll just hit save. Now I have the seeding here. The rest is coming in the parameters. I forgot geometry meshing. I have part 5 layers automatic. For the part insert, we don't care about that now. And for the meshing, I normally use this 4 inner and 5 outer layers because it's not that important when you just have a pin gate. But if you have a longer runner system where you have shear heating, this is really good a good mesh for capturing the right shear. So now I have this. I just go to generate. I click here because I want the meshing to happen in different tempi. And now I got this mesh here. I can click out here, for example, and we have a model tree here where you can see the parts up here, all the cold runner, mold base, and so on. I just click them off so I only have the part. And in the tools, I have this chisel. If I use this one, this is only a visual tool, then I can look inside and say, okay, it's only a surface mesh, but it's closed. I just hit this one again. And I go to meshing, generate. Now I want a solid mesh and also the runner. We can take that also. Generate. We can have a look at the mesh now. Okay, it has to do the runner meshing. We can see it refines the mesh around the runner when it's done. And directly from a line or pin gate to a solid mesh. Chisel, go down here, look inside. Now we have the perfect mesh here for us with the boundary layers and the tetra mesh inside to connect the boundary layer mesh. So the way that it looks was perfect for simulation. I go back to mesh. Keep attached solid mesh. Yes, yes. I don't want to delete what I've just done. The cooling channels, they're mesh now. And then the mold base. The mold base is then filling every single space out with a mesh. And I can show the mold base now. It's a bit weird that you can actually rotate and show the model when you are doing the meshing too. Like that. Now we have this, and the final check. Then we save a MFE file. A MFE file is a file that's only containing mesh and some attributes on the mesh. You cannot edit it, but that's the file that's actually used for the simulation. It's also, while it's saving, now we can just file explorer, mesh, you can see the MFE file here. Close that again. Now we're back again. We want to, we have the model, material. We can go here, material, we can go here. I'll just click here. I can just choose one. This is an ABS, doesn't matter. If I want to choose another, I can go to material wizard and right click a material from that. Yeah, we can also choose a different one. Let's say Moldex user bank. Let's say we took this one, right click at the project. Okay, no, I don't want to put it in the user bank. And now I have this one. The next step is the process. I can double click here, or I can go up here. If I click here on these, and now it asks if it wants to, based on the current setting, I just say okay to that. And now I have the process. I use normally CAE mode, but there's also machine mode available. If you're the first time, maybe this one is for simple mode. You cannot use that for anything. Put it on classic mode and you're ready to do something, make a real process. You can give it a name. Normally I give it 500 here. This is the machine, what is actually possible to do. I don't want any restriction in the injection pressure. And this is the packing pressure. Normally I put in 100 megapascal, like 1000 bar. If I want to go over 1000 bar in packing pressure, I need to adjust this up. But normally I don't want to do that. But in some cases I could. The filling time I go for maybe 1.5. Yeah, 1.5. I don't want a profile injection speed, so I put that to 1. And then I have the switchover point, 98%. It's okay. Packing time, normally I choose a bit too long packing time, because then sorry, I have the possibilities to see when it's actually frozen off. So in a case like this, I would go maybe for 15 seconds. I know it's too long, and I go for packing pressure refers to machine pressure, because I don't want that it refers to the end of filling pressure. So I'm not in control of it. And then I can adjust the packing pressure here. I go up here and put it to megapascal versus time. I can profile the packing, but in the first case, I just want to run with 400 bar, enter, 40 megapascal. Say OK to that. I don't adjust these. First, I go to the cooling setting. I never use general cooling, or never. In most cases, I don't use general. You can use transient for all cases. So it's like a bit double clicking here. Transient, you just say yesterday that I don't know what it's actually telling me. Initial mold temperature. Normally, if I put the initial mold temperature, this is, think of the temperature of a mold that you put up into a molding machine. Normally, I would put it up in 25 degrees. So I put in, yeah, air temperature, eject temperature is from the material. Cooling time is how long time should the cooling be after the packing. So let's say 10 seconds. Mold open time, the machine time, open, eject, close again. I'll let it be for 5. Cooling channel, here I can set up the cooling channel, and if you're in doubt which cooling channel is which, it's possible to go up to the display, say coolant inlet, maybe it has to be, yeah, I need the boundary, and then you can see cooling channel 3, 1, 2, 4, and so on. I just go here again. I go to the mold metal. Normally I just use the P20, it's a general one. If nothing else if it's a normal tool steel. Finish. Now I got the process. Then I go back to home here. I have to set up which kind of analysis do I want to run. In this case, I want to run this transient analysis, where I have a cooling transient first to get a temperature distribution in the mold. And when I've got that in a steady state situation, I'll fill the part, I'll pack it, and then I have a cooling, the cooling waiting for it to solidify and be able to eject, and then warpage. That's just a result of all these. The next step is the computation settings setup. If you know, I'll normally just hit this one, reset only inconsistent setting. Just hit this. Normally, this is what I'm using normally. You can, of course, choose differently if you know something better, but this is how I do it. I use enhanced for the fill pack, enhanced, customized, and I hit compressible flow on. I take maybe a bit more results here. Let's say 9. I just wrote 9 and enter. Okay, 19 in packing. Hit here, edit. Let's see. It's 15 seconds. I'll just put in 29. Then I get results every half second. Put OK here. I use this estimated required cooling time because then I get some cooling, yeah, cooling time, small cooling calculations in the just by running a filling analysis. And then I use these for the cooling. I don't normally use average, but for the cooling I need to adjust. Click here, hit edit on the hidden button. I use 19 maybe. You have to have some intermediate results, otherwise you don't exchange the cooling during the fill and pack. Opening, nothing. I normally adjust this up, edit, and I put this for 30 degrees. Warp, I hit this output differential temperature and shrinkage effect. As a result, this is only a result. When you're finished, you can hit template setting and use that as Moldex3D setting. Because then when you start an analysis, it will remember these things in the computation. Then you don't have to adjust it every time. Like that. Analysis. Oh, I had that. Then I hit computation. I can just hit that. Ah, sorry. I can hit computing manager. Maybe you can run it locally or whatever, but I normally just use this computing manager. When I hit that one, it prepares the job and throws it out here. And then I can choose, now I don't have connection to my servers, but otherwise I can just choose the server that I want to calculate on. You can also choose localhost, then you calculate on your local computer. It's not really recommended. It's recommended to put up a calculation server so you are not connected to the calculation. So you can do whatever you want with your machine while it's calculating on the server. Yes, you just hit here, adjust, maybe say we want to use 16 tasks. Of course you need license for 16 tasks then, but hit here and say submit, and then it runs. Thanks for watching. Have a nice day, and bye bye.